Hey guys, so welcome to our next video. In this video, we'll be talking about operators and operands in C++ and C. So let's get started with it. So let's create another C++ file. We'll call this operators.cpp. Okay, as simple as that. So first things first, let's create a simple program. So include cstdio and then let's declare our main function called int main, and let's have two variables, int a equals to, let's say, 2, and int b equals to 3. Now you have already seen what I can do is I can print a, print f, that is given by our stdio. You can also write stdio.h, by the way. Just stdio is a standard forced by C++, that is optional to have a alternative name to C libraries to keep that .h away from it. When we get to the header files, we'll talk about it. Let's say percentile t, that is our a, and then comma percentile d backslash n a and b, and we will call these are our operands, operands. So these are our operands. So let's just run this code. So pl operator dot cpp, and it gave me a fatal error because I did spell the name wrong. So cstdio, and now it should compile it, and then I can say dot slash operator dot xc, and you can see we have our two operands that are 2 and 3. So what are operators in context of C++ or C? So operators are those symbols like plus, minus, and so on. So what I can do is I can write a couple of operators here that are commonly available. So the first is, uh, let's just format this a bit, okay, to keep things good. So we will write a function that will do that for us, or we can just simply do it here. We can say that yeah, we can do this like this. So first is our addition operator. So addition is written as plus sign here. Then there comes subtraction. It's denoted by minus sign here. Then comes our multiplication or division operator, and then comes our modulus operator. In case of actually let's change a to 3 and b to 2. Okay, to to make things sensible. So these basic operators, these are our arithmetic operators. That is plus, minus, multiplication, division, and modulus. So if we run this code right now, we need to compile it first, and then if we run it, you can see that our operands were 3 and 2. And when we performed addition operation on 3 and 2, we got 5 because 3 plus 2 is 5. When we performed subtraction, it was 1, self-explanatory. Multiplication, self-explanatory. Division is 1. Why 1? Because these were integers, and integers means whole numbers. So obviously the fractional part will be removed. So 3 divided by 2 is 1.5. 0.5 will be removed. So it's 1. And then comes the modulus. Now what is modulus? Modulus is the remainder when you divide it. So if you want me to make a video on modulus arithmetic, I will make. But basically what happens is when you divide c by 2, you get uh, 1 as division and 1 as modulus. I can make it more clear. For example, let's say I have, let's say 5 in place of a. Okay, so if I put 5 in place of a, and then we run this whole thing again, you can see that 5 plus 2 is 7. Now 5, if we divide by 2, we can subtract 2 times from 5. So the division is 2, and the remainder of the division is 1. So now modulus is 1. Okay, so these are the basic arithmetic operators. Now what arithmetic means is that, and these are not only arithmetic operators, but also these are uh, binary operators. Binary operator means what? Okay, let's write binary operator. What binary operator means is that a binary operator performs on two operands. Okay, that is operand 1 and operand 2, and there is your operator. We call it operator. This is just for the syntax. Okay, so these are arithmetic operators. Then we have something called as logical or relational operators. I prefer calling them logical. So let's say logical operators. So there are a couple of them. You can try to write them one by one and see what happens. So mm, yeah, these are all I guess. So if we run this now, uh, yeah. So in C programming, a 0 means false and a 1 means true. Okay. So as you can see that is less than A is 5 and B was 2. So 5 is less than 2. Obviously this is a false statement. So we got 0. Whereas 5 is greater than 2. So we got true. That's why 1. Now is it less than or equal to 2? Obviously not. So 0. It is greater than or equal to 2? Obviously yes. So 1. Equal to? No. 5 and 2 are not equal. So 0. And not equal to is 1. Okay. So let's gloss over them once more. What the operator representations were actually. So for greater than and less than, these are just greater than and less than symbol. Greater than equal to and less than equal to are greater than or less than symbol followed by the equal to symbol. And then comes the equal to symbol. Now, when we use a single equal symbol, it stands for assignment, assignment operator. Okay, and it is a unary operator. Okay, so like it's also binary operator. Sorry, am I wrong? Because it assigns the value of operator 2 to operator 1. Operand 1, sorry, it's not operator. It assigns the value of rand 2 to operand 1. And I should say OP stands for operand. Okay. So we have assignment, which is a single equal to, and then there are double equal to, which is used to check whether two values are equal, and not equal to is used to check whether two values are not equal. Now there is another operator that is very interesting. These are called another type of operators. They are called bitwise operators. So what bitwise operators do is they perform on the binary data itself. Okay. Let me give you an example. Okay. So and yeah, you can call these relational operators. My bad. Relation operators, but like sometimes I just call them logical operators. But logical operators are a different thing. We can also talk about them. But you can group them like there is no strict boundary as long as you know that what operator does what, it's enough in most cases. So yeah, So like bitwise operators, they have like strange behavior. Let me first write here so that you can understand. So what is A? Okay, what is A in binary? So 5, 5 can be represented as 1 0 1 because it's 4 plus 1. When you are dealing with binary numbers, how you convert them into decimal numbers, it's easy. You just take the first number, multiply by 2 times 2 to the power its position minus 1. So in this case 1 is at third position, so 2 to the power 2, that is 4, and then 1 is at first position, 2 to the power 0, that is 1. If you add them together, so this is nothing but let me comment this out. So this is the binary version, and for 2 the binary version is 1 0. Okay, and how you get it? You get it simply by doing 2 to the power 2 plus 2 to the power 0, and this is 2 to the power 1. Okay, because the first position of the 1 and 0. This is how you convert binary to decimal, not decimal to binary values, and also binary to decimal. Okay, so yeah. So next is our bitwise operator. Let's focus on that because knowing these representations will help. So and also we should probably print them. Okay, operands. Let's do this way. Let's put it here. dd. So we say operands in binary. So we can say that printf, and for now, for the simplicity sake, we can just say uh, 101, that is for 5, and 010, because putting 0 in front of them does not change anything, and actually there are like if you look at them, they're most probably 32-bit operands. So uh, there are like 32 minus 3 number of zeros in front of these. Okay, but for our simplicity we are just ignoring the zeros because a 0 at the front is just meaningless. So now what you can do is you can check the bitwise operators one by one to see what happens. Okay, and the bitwise operators, they work on the bits. Okay, so we will call this bitwise and we will put mm, actually this is bitwise and this is your and symbol. Then you have bitwise or, then you have bitwise or, then you have bitwise not, and this is a unary operator. Okay, unary operator. Unary means that it acts on only one operand. Okay, binary means it acts on two operands. So and then bitwise shift, left shift, and then we have bitwise right shift. Okay, so now if we run this for these operators, like immediately you might not need them, but at some point of time they will be your like greatest tools when you're trying to optimize your program or find some things. So what happened? Let's check it. So first comes bitwise AND. What it did is it took one by one bit and it AND them. So 1 and 0 and is 0, 0 and 1 and is 0, and 1 and 0 and is 0. So the number becomes a 0 0 0. So for 0 0 0 the AND value is 0, right? The decimal value is 0. The same for bitwise OR. If you see, this will be 1 1 1. So 1 1 1 means 2 to the power 4 plus 2 to the power so 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. That is 4 plus 2 plus 1. That is here 4 plus 3 equals to 7. This and bitwise OR is a bit different. What it does, first I need to explain to you what XOR operation is. So XOR means this, like if I have A and B, okay, if out of A and B, one of them is 1 and another is 0. So if the value of A and B are different, like if we are constructing the value of A and B in only 1 and 0, we're thinking them as a bit. So we have two bits, one is A and one is B, and we are performing the XOR operation. So if one of them is 0 and other is 1, no matter which one, we can also like say that if they are different, okay, then the output will be 1, else the output will be 0. For example, 1 and 0 will give you 1, 0 and 0 will give you 0, 0 and 1 will give you also 1, but 1 and 1 will also give you 0. So that is XOR operator. The NOT operator is turns your bits into their opposite, like 0 becomes 1 and 1 becomes a 0. Okay, that's how NOT works. And why this strange value of -6, you may ask? Because what we did was we bitwise not we applied bitwise not on the on this on the 5, I guess, here. Okay, so let's open it to so that I can explain to you. So here you can see that we applied bitwise bitwise and not on the key this unary operator or not operator on the a variable. So what happened is it was initially 101, then it turned it into 010. But here is the twist: this 010 is not like this stands for what? This stands for 2. Okay, so what did that 6 comes from? So 6 comes from 110. So 110. Okay, 110 is 6. So why this one become 1? Because this one, this not operator, uh, not only did it like convert it into um, like it's basically the complement. Okay, so it's basically the complement. So when we talk about complement in computer science, we talk about two's complement. So when we do two's complement, what we do is we basically first of all we perform two things, and this is very important. First of all, we reverse the bits, so 1 becomes 0 and 0 becomes 1, and then whatever the result is, we add 1 to it. Okay, so not only and not add on to it, but the first like the immediate first bit becomes 1. So it first becomes 001, 010, and then it become 101. That's what I mean. The opposite of 101 is 010, and like bitwise, and then you add 1 to it, and it becomes 101. The you will probably not use uh, this not operator on numbers like this, like you will not use it on 5 or 6. You'll probably use it on 1 and 0, because 1 and 0 are once again 2 and false. So if opposite of 2 is false, opposite of false is true. That's where this one shines. Okay, like for example, let me give you a better example, like not 1, and let's say mm, actually we will call this complement. So we'll call this complement of 1, and we'll call this complement of 0. Okay, and obviously this has to be 0, otherwise we get what we want to see. But if we now compile this and if we run this, you can see that the complement of 1 is -2 as usual, and complement of 0 is -1. Okay, so because it just we are working with integers, a better way to show it is like, how do I show it? Yeah, one thing we can do to like see it is doing this. Look, this is complement, and I told you how you can calculate complement. You just reverse them and just add 1 to it. That's the trick. Okay, so like I'm not adding one, but two's complement. You can search on two's complement. Like for now, it's not explain to you. So yeah, so not one is zero and not zero is one. That's what I tried to mean. Okay, so let's do that. And that was a bitwise not. Yeah. So like it was not ordinary not. The earlier one we used was bitwise not. Okay. So bitwise not is like kind of uh, how do I say it? Like you are performing. 1 second. Let me. The better way will be so C++ operators. I guess here I can get some multipliers point. These are probably not the ones you will like to check for C++ documentation. This is a good site where you can check different operators and what kind of performance they have. Okay, like you can see true false because it's once again I told you that these are relational operators. We say that relational and comparison. And then there is logical operations. So this was the not operator that I told you. If it's true, it will become false. If it's false, it will become true. Okay, but now you can also use it on numbers. Basically, zero is false, and above zero, everything is true. Okay, that's how basically like C or C++ treats. Okay, so like there is no like actual true and actual false. Okay, and the short circuits will come to it, and then there is this binary we will see at them. But now I'm interested in this one, that unary complement, the bit inversion. That's what I tried to say. Okay, it inverts the bits. Okay, and then like the first bit is also like whatever it is, it's appended one in front of it. Okay, like the first bit. When we talk about like how the variables is stored, at that time I will more of all explain it to you. That will be better because I have to like go through some concepts to tell you. But this is the not operator in summary. Okay, this is not. Okay, so this is not. I would say not of a, and also like complement is also same. Like true's complement is false and false complement is true. So you can also call it complement. That's not the point here. Point I'm trying to make is these are the operators that are available to you. Now these ones, okay, bitwise left shift and bitwise right shift. If I look into the output, let's understand what happens. Is that I am saying that I have this 101 and I want to shift the value to the left side by two places. So I will add two zeros after 101. Okay, so 101 becomes 11000. And here I am saying that my 101 was here and I will shift it, but I will shift it in the left side. So if I shift one times, it will become what? This first one will be gone. And if I shift it second time, this will be gone. So I am left with one. So this is one, obviously because right shift. And can you guess what this value is? So this is obviously 4. Okay, and this is obviously 4, then 8, then this is what? This is 16. Okay, so 16 plus 4, 16 plus 4 is 20, I guess. So if we run that program once again and we see the output, you can see that it's indeed 20. Okay, so first one is 20 and the second one is 1. Okay, what we discussed earlier. So now getting back to our operators, there are, this is like the basic uh, ideas about operators. There are some other operators but that are not cannot like tell them about tell you about them right now because that will just disrupt the flow. But there are other operators. Now some operators that I can tell you about is logical and, logical or, and logical not operator. So once again we will try to do our stuff on a and b, that is 5 and 2, and we will try to see what happens. Okay, and here I will put a. Okay, not issue, logical not, for simplicity. These are also called short circuits, because what they do is if one of like, let me first explain to you, then it will be clear. So let's first run this. Let's first compile this actually, and then let's run it. So as you can see, the first one, 5 and 2. Now 5 and 2 both are greater than 0. So both of them are true. So the output of logical AND is also true. So in that case, 2 is represented by 1. So 1. The same goes for 1 and 1. It's also true. So 1. Now obviously this is 5, which is true. 2's opposite is false. So 0. So you can think of them as and OR, but they are applied on the entire variable, considering whether the variable is true or false. Okay, their output will always be 0 and 1. But one thing that they have a very interesting behavior, that is called short circuiting. So what do you mean by short circuiting? So let's say I have a expression called A, okay, and I have an expression called B, and I have an expression called let's say I have another int C here is equals to 0, for example. So let's try a few combinations. Okay. So first we'll do A and B or C, and then we'll try C and B or A. Okay. Mm, this is not a good example of short circuiting, I guess. When we work with functions, I can show you what short circuiting does. But let's look it for now. Okay. Once again. So let's compile it, and then let's run it. And then but this the executable. So as you can see that our C was 0, and A and B is this is not what we should have gotten. Once again, just let me check what have I written. So I just put A and C. That's why. So 0 and 1 is obviously going to produce like AND operator, so it will obviously give 0. If everything is 1, then it will only give 1. So let's put B here, and then or C here, and let's put C here, then let's put B here, and let's put A here. Okay, now this is the simple scenario. I will show you the real short circuiting after this. For that we need to use the functions. So like we can see the internal behavior. We can see the internal behavior. So now that we have compiled it, we run this, and you can see that A and B or C gives us 1. Okay, and C and B or A gives us 1. Why? Because like this AND gives us 0, 1, and this OR gives this C value is 0. So 0 and this is 1. So obviously this will be 1 because we are doing OR. In this case, what happens is C and B is 0. But then if you look at this, B and A, it's 1. Okay. So this is 1 and this is 0. So obviously this is not what happened. What happened is C and B was executed first, and its output becomes 0. And then this OR was executed with A, where A was true. So A was 1. And so we got 1. At this point, due to so many outputs, I think we are losing the context. So let's just do one thing. Let's just delete all this stuff. Okay. Because up to this point, I think most of the operators are shown to you. But let's say we start with our AND and OR operator, and like we do shit out of them. Okay. So first thing, how do you like do that thing? Like A is 1, B is 1, and C is 0. That is our, like, A is true, B is true, C is false. Anything that is not 0, is above 0, is considered as true. Okay. So you should remember it, and you should not like use negative values, because some different compilers use different kind of annotations, but indicate. So for example, let's say I want to have A and B or C. Okay. But I want to execute B or C first and then do the AND, so that it will become 0. So what I can do, I can do the same thing here. You can just put a bracket here. This is another operator, and it just does the same how it does. So it's used for function calls also, and it's also used for grouping the operations, so that the operator precedence doesn't affect you. Now operator precedence you already know from your like arithmetic class experience, that multiplication and division takes more precedence than addition and subtraction. Okay, and so on. And there are lot of these rules. I will just show you the table there in the website, so it will be more clear to you. But what do you think this will produce? So as you can see here, just try to analyze this. So C0 B is 1. So this one expression, because of the bracket, will be executed first. The parenthesis it will be executed first, and its output will be 1. And now this 1 and this one will give us a 1. So 1 and 1 ultimately, because both are in AND, so it will give us 1. Now what happens if we put it like this, that I want to execute A and C. Okay, let's put this C and this, and okay, let's make this B as 0, for example, and C as 1. Okay, just for the simplicity sake. So not simplicity, but the visual pleasure. Okay. So in the second case, what we will have is this one. We will have A and B, and every thing that we're providing for every D, we are just considering one. Like you can also like in the line itself, you can write the whole uh, command, and it will be executed, the whole statement. So it's not like you need to like compute it beforehand and then do it. Okay. So what I'm trying to say is that this in this case, this will be executed first. So B or C will be executed first. Okay. And in this B and C execution, as you can see, mm, actually this both will be true, because in this case also C is true. So let's just do this. Let's set A as yeah. So both of them will be true over here. Okay. Like, as you can see, both of them will be true. I don't prepare scripts, so I don't have appropriate examples all the time in my mind. But let's do something like this. That also let's have a false one. So also we can try to do a false one. So we have A and B or C. Here, let's say B is or A. Let's do it A. Okay. Or let's keep it C, but let's do it and this time let's make this or. Okay. So this will uh, do our evaluate, like this will give my intent clear. So this will be false, because what, when we perform A and A or B, okay, the A or B will be 1. Okay, but if the C is 0, let's have another one, that is D. That will get my intentions clear. And then I have D here, the example. So A or B, it will be 1, but because D is 0 here, so this whole expression will turn out to be 0. Okay. And in this case also, you can see that these are truths I have already mentioned to you. But what happens if, like, now let's consider that C is 0, just for exercise. So what will be the output of these two statements? So as you can see that A and B will be executed for here, B and C, B or C will be executed first, and let's make A 0 and B1, for example. So what will happen here? So as you can see here, because of this and, this both will become false. Why false? Because when A is 0, I don't need to like evaluate this whole expression. Why I don't need to evaluate this whole expression? This will also be false because C is also 0. Let's make C1, for example. Yeah, yeah. This will now make it clear. So here it will be false, but here it will be true because when I get a 0 and then get an and, I know that I don't need to like work out this whole thing because I know that I have gotten 1 0 and rest of it, whether it becomes 1 or 0, I will still get a 0. So it will obviously return false. Okay. And the second case, I got here a 1, right? Because I got here also a 0. Okay. But because this is an OR statement, I know for sure that because this is a 0, but still for a 0 there might be a 1 or 0 that can determine the whole situation. So I have to give a 1 here, like I have to evaluate this expression here. Okay. And so when I go to this expression I get a 1, so this becomes true. Obviously I need to I can keep these things set. And now our third one that I want to do is, let's say I have my C here. Okay. I have my C here, and then after C I have A and B. Okay, this is my next expression, and with C I am providing an OR operator. Okay. So now C is 0, and obviously this will be C or A and B. So now, is this true or false? So I have C here, and I know that this A and B, there obviously, how do I say it? Like this C is obviously 1, so this is true. So I don't need to like go any further. I can just say that this is true. Okay. Because I know that for here, whether it comes as 0 and whether it comes 1, it will be true. This is an important thing that compiler uses to optimize, to reduce some of the extra calculations, and we can take advantage of that. That is what I'm trying to show you. So now I will call this short circuiting. Okay. So let's convert A, B, and C into some functions. So let's say int A, this is A, and then returns 1. Okay, and I just put a space here because I don't want a new line. Then I have int B that does this. And then I have int C. These are three functions. The first function prints A and then returns true. The second functions, actually A should returns false, right? In our example. So A prints A, then returns 0. B prints B, then returns 1. And C prints C, then returns 1. So you can see whether these functions are executed, working on that hypothesis that the compiler when reaches here and sees that this is a 1, this is a 0, it should not call this, it should not work on this part. And because these are the functions, I need to call them. So I will just put brackets here to call them. And at this point, it might look a bit intimidating to you, but like this is an example. Okay, you are not going to write some code like this, and you will have some names that are more sensible. So you will not this. But the idea is check what happens in this case. Okay, so let's try that. So first thing, obviously, let's try to compile it. And as you can see, it says that the missing argument one is okay. So line number 31, 32, and 33 have some errors. And the term does not evaluate to a function taking 0 arguments. Okay, let's see what happens there. So I can come here and I can see they take 0 arguments and 31, 32, 33. These are the things. So what went wrong here? Just let me check it once, because sometimes what happens is don't get like this is one call, this is another call. Here, this bracket belongs to this bracket belongs to this bracket belongs to this. Mm, 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 mm. Is it throwing an error? Oh. Printf not enough argument passed to the format string. Printf not another argument is a format passed the term does not evaluate to a function taking zero arguments. Okay. Let's check it one more time. What happened? Sometimes it happens like errors in your code is like something that will always deal with. And like for a person with very less brain. Oh, yeah. So another thing that is scope. So what happened is that I have this ABC here, but then I have also declared ABC here. And because like these are inside this scope rather than being outside or like in a other scope, what happened is that these were given first precedence. So here A was considered as a variable, not as a function. Okay, so that's what happened. So what we need to do is we need to just delete them, and then they should work. Yep, it works successfully. And now if I run this, you can see that in the first case, mm, once again, let me make it more clear. So I will put a symbol here just to like keep these things separated. Okay. So in the first case, if we look at it now, in the first case, the function A was executed. The function A was executed and it returned 0. So because it returned 0, we no longer needed to execute this part. So these two functions were never called. In the second case, A was executed and it returned 0. So B was not needed to be called because the C++ knew that regardless of whether I call B and B, it does not change the final output. So it never called B and it directly executed C because the OR was important, because even though there is a 0, there is a chance that C might return 1, and so it evaluated C. The third case, what you can see is it evaluated C returned 1, and it knows that whether this is 0, this part is 0 and 1, the output will still be 1, so it never evaluated A and B. Okay. So this is what I mean by short circuiting. Using your variables like this, you can like you can just skip some unnecessary calls of the variables. Okay. So this is about short circuiting. So the next part that I would like to focus on is that error that I earlier had. I will just show it to you once. Let's say A equals to 10 and B equals to 20. And then what I do, I say printf and I say that A equals to this and B equals to this. And then I will put a bracket here. And now here I say A equals to 100 and B equals to 200. And then I also call printf here. Now, in this case, and then after that, what I do is I call this function once again, that I come out of this bracket. Okay. So and these kind of brackets you can keep how many times you want. These are basically called blocks. Okay. And blocks you can consider them as separated code, and always the variable that is declared inside the block, if it has the same name with a variable declared outside the block, the variable that is inside the block will have more precedence, and it will always be the variable that is going to be used. So the output should be 1020, then 100, 200, then once again it should be 1020. And if my compile, sometimes the compiler thinks that I am a stupid guy, so it doesn't want to compile. But yeah, I need to redeclare them. So now let's see whether or not it will compile. Obviously, it will compile. Now, if I run it, you can see that 1020 came, then 100 to 100, then 1020. Now, if I assigned the same variable, it would not happen. Like for example, here I declared them once again. But if I just assign them, then the third part will also become like 10 and 20. So, make 100 and 200 because the values were changed. Okay. So a variable is sometimes this kind of thing happens. So I need to compile it. So the compilation is done. Now if I run it, you can see that it was 1020, but the values were reassigned. They were not redeclared. When you specify the type and then the name of the variable, it is declaration. You declare that this thing exists. But when you use the only the equal sign, it's just saying that I am assigning. I am not redeclaring the whole stuff. That is it. So these are the basic things that you should know, that the what blocks are, and blocks are very important because many of the codes, like when you are declaring a function, or when you are in later videos, you will see that when you are doing some checking, and like when you are trying to run some code again and again, you'd probably like to isolate it inside a block. So you should know about this behavior. Okay, this behavior and this behavior that I said. But in this case, here the values will still be 10 and 20. And why this happens is because what happens is whatever variable you declared is put inside contiguous memory. It's called a stack. Okay, so that memory is called a stack. So what happens is that in this stack, when I say A and B, first 10 is there because A was designed, and then 20 was there. Okay, then what happened is I declared a block here. So for this block, the new value of 10, 100 was stored in the stack, and 200 was stored in the stack. And now, previously, whereas these were A and B, these 10 and 20 were declared as A and B. Now, because I am inside this block here, these two were not accessible anymore. Rather, these two became our new A and B. Okay. Then once we get outside this block, this memory was no longer needed. So this memory was released from the system. And due to that, these two variables went back. And so once again, A and B became this. Okay. And that's why this behavior that we saw came into picture. So that's about the blocks, just an additional thing that came up to us. And to end this, what I want to say is that there is another thing that I would like to mention about operands, and that is there is something called and LHS and RHS. So a left hand operand and right hand operand, LHO or HO is for side. No matter what is, that does not really matter. What matters is that you writing, like I have a int a, writing this as int a equal and in a, and then I say a equals to 10. This is a valid operation because I can perform this operation 10. I can take this value 10 and assign it to a because a can store a value. Okay, but I cannot write 10 equals to a. Why I can't write this? Because it's also saying that the AI is also saying that it's an error. Why I can't write this? Because whenever you declare a variable, a memory block is allocated. Okay, so you have a somewhere a place inside your RAM where that 10 will be stored. Okay, but in this case, when you are saying 10, 10 itself is a number. It's not a storage, so it cannot store any value that is out of this. Okay, so you need to be careful about it. In the later videos, we will come to some come to some examples where we will see this kind of behavior and when it will make sense. Okay. And finally, what I told you, I will do that. I will show you the operator precedence table here. So you know that which operators, like if the brackets are not used, which operators will be executed first. Okay. So if we look at this table, what is at the top is given higher precedence, and what is at the bottom is given lesser precedence. Now some of the operators I have intentionally avoided, uh, just such as the scope resolution and new delete size of these operators. But as you can see, the brackets get much higher precedence, and also I will also show you these two things. Okay, these two things I will also show you before I end this video. And this is called increment operator, and this is called decrement operator. It just increments the value and decrements the value. So, and then the last level of precedence is given to this assignment after doing the operation. I will also show this. I forgot to show this one. And also I will show you the trinary operator. So these get the least precedence. The brackets get the most precedence, and before them the most precedence is given to the increment and decrement operator. And the list, then there is then the precedence goes to the arithmetic operators as we expect. Okay. These get the same precedence. Then this is the next precedence level, and then comes our bitwise operators. They get more precedence. Then comes our logical operators. Okay, these relational operators. And even in case of relational operators, the like operators with greater than and less than get more precedence than equality. Okay, and then comes our with this and these bitwise operators. Okay, these were the shift operators, and these were the conjunction, disjunction, and these operators. Okay, you can get that list here. And every time you feel confused, even I feel confused, I come to this list. Like there is a comma operator, and you say that what is the use of comma operator? So I will just show you these few operators, and then we will close this. Okay. So the first I will show you is uh, it was our operator dot cpp. So the first one I will show you is the comma operator. So let's say I am trying to declare two integers, one that a is 10 and second is b is 20. So if I have two expressions, I can, and I want to write them in one sentence, I'll probably separate them by a comma. That is what comma operator does. And also comma operator separates the arguments. Okay. As you can see, there is another version of int which takes argc and argv. Like when it's declared add function, for example, the comma was used to separate different arguments and statements. Okay, in the printf itself and other areas. Then the next one, you can see here. I can write it here. For as of now, you are like quite familiar with this statement, I guess. And the next one is a trinary operator. So I can say that int c is equals to a is greater than b. If that is true, then c will be 100, else it will be 200. And then I can print c. So what will happen? Let's first check these two. So let's compile this, and then let's just run it. So as you can see that our a was 10 and b was 20. So the comma operator worked perfectly. And then I said that a is greater than b, which was obviously not true because b is greater than a. So the second part was called. So that is the trinary operator. So what trinary operator does is basically it's a conditional statement. Depending on this condition, if first this condition is evaluated, if this condition is true, then whatever is mentioned here is returned. Otherwise, whatever is mentioned here is returned. So in this case, this was false. So this was returned. Okay. So that was trinary operator. It's just, for example, this is condition, and if condition is true, then the true, then this will be returned, and if it's false, then this will be returned. That is the trinary operator. Now the increment and the decrement operator is very simple. You say that a plus plus and b minus minus, and then I will copy this and paste this. Now, as it suggests, an increment operator, what it does is it increments the value by 1, and a decrement operator decrements the value by 1. So now if I run this, you can see that a was incremented by 1, a became 11, and b was decremented by 1, so b became 19. And one step further, with the lowest precedence, what we can do is we can do something like this, where we can say that a I want to plus equals to by 10, and b I want to divide equals to by 5. So this is essentially saying that a is equals to a plus 10. So whatever the value of a, add 10 to it and assign it to the value of a. And this, whatever this is saying, whatever the value was of b was, first divide it by 5 and then reassign it to b. Then is plus equals to, divide equals to, minus equals to, and like all the arithmetic operators with equals to works. Also bitwise operators with equals to will also work. Okay, but it has the lowest precedence. Okay, so like uh, it will be executed at the last. Okay, like if there is a multiplication, it will happen first, and then that equals to, like multiplication equals to something like that will be executed. So I will give you a demo first. Let's check the output here. So obviously first you need to compile it. So yeah, let's compile it, and then if we run it, you can see that a was plus equals to by 10, so a becomes 20, and b was divide equals to by 5, so b to become 4. Okay, so this always makes some of our typing sort. And then the last one that I want to show you is, let's say a plus equals to b plus 10, for example. Okay, so as you can see that b plus 10, actually let's call it b plus 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 10. Okay, and that's how you make some code that is like totally uh, too much complicated to be understood by the users, but I'm still here to explain to you what is happening. And also I forgot to print the values once again, so let's just copy it and let's print it here. Okay, so and also yeah, so let's compile it, and then let's try to run it. So now this is interesting. So a was 20 and b was 4. So b plus plus was executed first. So b became 5. Okay. And then what happened is you get 34 here, because I had b plus 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 10. So how b plus plus become 5 and then this 34 came here? So the answer is simple. Okay. The answer is simple, because when b plus plus was 5, the value that was given to a was still 4. That's what differentiates between plus plus and minus minus. So I'm just commenting it here. I'm not writing it. So b plus plus means that return b, then increment. Okay, and plus plus b means increment b, then return. So if I want this to be b equals to 5 and then 10 added to it, and then a that is added to a, that is a becomes 35, and I will just say plus plus b. Okay, and this kind of code is a prime example of the kind of code you should not write to make your users mm, like totally confused. Okay, like not plus plus and so on, but like you say plus plus b minus minus plus minus plus, you can write that, but like, it does not make any sense. For example, like if I tell you, for example, this is the last example that I'm going to give you. So yeah, so this is in increment, and also minus minus also works this way. So let's example, I have a variable a equals 10, and then let's say I say, for example, printf. Okay, whatever the value is, percentile d. Let's just only print it. And let's I say plus 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 a plus plus a plus plus. Okay, so this is a valid statement, but like you can't understand what does this mean, right? Even if I compile this, okay, it's saying that yeah, it's through some error, but that's because I have to put three pluses here. Okay. If I put three pluses here, then probably it will understand. Okay, so this is a correct statement. So now it will compile successfully, but like you will say that why it's 40, I don't understand. Okay, so let's just break it down once more just to understand. So this statement is equals to this. So I have a plus plus, then I plus a, and then I have a plus plus, then I have plus a plus plus plus. Okay, so this is the statement. Okay, and because it's executed from left to right, this is executed to left to right. So first a was incremented to 11. Okay, a became 11, but here our total value was 10. Let's just keep two values. So a became 11, but our value that was returned was 10. And then I added, this time I added 11 because a was already 11 and a became 12. So 10 plus 11 and a became 12. Okay. And then what happened is we added 11 once again. This time we did not increment it. So we added 11 again. And then we added, after this, we added, one second, a plus plus. Like, this is where you have to like consult the precedence table when I think I am wrong. So as you can see that plus plus gets more precedence. Yeah, plus plus and minus minus, they get more precedence than this addition and subtraction operations. So obviously plus plus will happen first. There is no doubt about it. So a plus plus and a becomes uh, i- it's once again let's do it from this way. So the first value was 10, then it became 11. Like I became confused. You understand? So it became 11, and then 11 was added again, but it became 12 this time, and then 12 was added, and then 12 was added, and it became 13. So now it makes 35. What was our output? I don't know. So let's compile it. Yeah, I forgot to remove that. So let's just make it a comment for now. So if I say, yeah, I need to put a printf. Uh, I need a comment here also. Yep. So now if I run it, and you can say that this is 40. So like at this point, I am confused what is happening. So my suggestion is never try to do that. Okay, unless you are like absolutely sure or like you're given a question to solve. Okay. Uh, oh, I get it. What happened is this, because this was 3 plus plus now, and plus plus had more precedence. So this happened first. This happened first. This happened first. So what happened is, yeah, that's what I got wrong. So what happened? Let's do it once again. So A was initially 10 and 10 was returned by A plus plus. And when 10 was returned, 10 became 11. Then for the next one, this one plus A. Okay. So 10 was returned again. And then what happened was either that or it also might be like the expression was evaluated from this side to this side. Okay. But the idea is that you have to like exactly know the what the specifications are saying. You need to consult the table and like how the expression are evaluating. You have to check it. Some operators work left to right, some operators work right to left, and at this point it will become very messy. So my advice is that don't like jump into that. Okay, if you're using plus plus or minus minus, probably put a bracket or something that actually makes sense, so that you don't need to first of all consult this table, and also you don't need to look whether it's left to right or right to left. Okay, like as you can see that postfix works left to right, prefix works right to left. Okay, so uh, like at this point I should be like able to understand what's happening. Let's just try it once more and then we'll close it, because like if I don't do it, then I will feel that I am showing you something that I don't understand, and that's not a good feeling. So I think whatever I had written, I have lost it. Yeah. So unfortunately, whatever I had written, I lost it. But that's what happens. Okay. So sorry. Uh, but yeah, these are the things that you should totally avoid. It makes I don't have that kind of memory. But hopefully I have taken through all these precedences and all the operators. Okay. The size of we will talk about it in a later session. The same goes for new and delete. But most of the operators, I think, at this point of time, I have already covered to you. And also, like, my videos are just to tell you that these things exist, and you should probably look into it. But apart from that, you should also like consult different textbooks if possible, or medias. Like this is one of the good medias to learn more about the syntax and stuff like that. The YouTube videos should not be your primary source of learning. That is like from my experience, I can tell you, the primary source of learning should be reading stuffs. Okay, because when people write things, they do more research and they try to like incorporate everything. But when I'm trying to describe to you something, as you can see in this video, we people start to like keep remembering some things, forgetting some things. Okay, in my gate exam, during my gate exam, I had to like remember this whole table in order to like they usually give one question like this. Okay, and my gate exam question, I did it right, but this time like it completely like I forgot the whole thing. And that is also the thing. Like when you read, you know that this thing it exists here. So at any point of time, when you forget that thing, then just come back and look into it. See, yeah, that thing exists there. Okay. Like for example, I told you that in inside CSTD lib. Okay. Like here also you can see that like uh, 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 I don't know. Like this is a if you go to the references, you can get the references of different C libraries. For example, I told you that you can get printf inside CSTDIO, or it's called stdio.h. So you can read this whole stuff and you can understand that what everything is trying to say. So as you can see that here you can see that printf is here, and this is how printf is declared, and like those symbols what does they mean and how are they used. Okay, we are using percentile D. Okay, here if you find D here, you can say D stands for decimal integers, signed decimal integers, right? So we use percentage D. And floating point numbers we used F. So decimal floating points. Okay. So that's it for today, guys. Hope you have enjoyed this session. It was a bit confusing, but still, like, I think it gave you a comprehensive um, understanding of different things that different operators and operands that exist in C++ and how they affect the behavior of your program. So thanks for sticking so far. It was still now here. And yeah, see you next time. And if you feel that my contents are useful to you, please try to share them to others and leave a like or subscribe to my channel. It makes me motivated to make these kind of videos even more. Okay, bye.